Heat is what formula? That's Q. Susan, Q equals mCp delta T. So which of those variables is heat? That's Q. All right, equals, what is mass? The gram, so 15.0. All right, the only other number that's given in the question says if temperature of iron is increased by 35. So what's that 35? That's the delta T. It says increase of temperature by 35. So I'm telling you the temperature went up by 35. So do I need to subtract here? No, this is one that you would not subtract. I'm just flat out telling you the change of temperature is 35. All right, we don't have CP, so where do we find CP at? On the orange chart. So look at your orange chart, find iron. Its specific heat is what? 0.449. So you look it up on your chart and plug it in. All right, so when we calculate, we have 15 times 0.449 times 35 is 235.725 joules. Now, we need to round for significant digits. So if I cruise back to my question and I look, how many significant digits do I have in those two numbers? 3 and 2. So I need my answer rounded to 2 significant digits. So my first 2 significant digits are the 2 and the 3, right? So you can leave it at 230, or you can round it up to 240 joules. Any questions about that? Tevin. So what? I can't hear you. Yes, I'm going to go over the homework. Most of the homework's going to round down a whole lot because a lot of those only have 1 significant digit. But yes, I'm going to go over the homework. All right, everybody got the first one. All right, number 2. What's the identity of that particular sample? So what would we have to do to find the identity? What would we need to know about that question if we want to find the identity? What's given to you on your orange sheets if you want to know identity? Specific heat. So we need to calculate specific heat. So if we're calculating specific heat, which variable are we solving for this time? CP. All right, so that means we got to know everything else. So if I cruise back to my question, what's my Q? So I'm going to put 856 over here. All right. What's my mass? 13.8. So I'm going to put 13.8 here. And what's my delta T? This time I'm going to need to do what? This time I need to subtract because I've got 2 temperatures. So 96.4, subtract 35.7, and y'all said 60.7. Y'all said it loud enough I could hear you. Is that what y'all said? Yeah. Okay. Y'all just need to talk loud enough I can hear you. All right, remember I'm old. So 13.8 times 60.7 is 837.66 times CP equals 856. All right, from there, how do I find CP? All right, divide by 837.66. Divide by 837.66. CP equals 856 divide 837.66. I get 1.02. And again, the unit is joules over grams degrees Celsius. Now, we don't really have to worry about significant digits because the question is not asking us for the answer. It's not asking us for that. It's asking us for what? The identity. So you're only finding me the element or the compound, depending on what it is. So when you look, all right, you're looking for a specific heat of 1.02, and it looks like on the front side is magnesium. Is there anybody on the back side that has a specific heat? No. So you're only looking at the front, and the answer would be magnesium. So that is your answer. So the significant digits there would be irrelevant because you're not actually giving me a numerical answer. Questions about question 2? Or how you would do question 2. We okay with that? You see it on the test? Are we all right? All right, question number 3. All right. What's the difference between weight and mass?
Oh. Mass is space.
All right, Rebecca.
Weight, it can change depending on the location. Mass doesn't change.
There you go. Weight changes with location. Mass does not change. All right. What does specific heat tell us about a material? Looking for something a little different.
Isn't it how fast you can heat up and how fast you can cool down?
So what does it tell us about how fast it heats and cools? Which one does what? The small one.
Cools faster.
That's right. The faster it heats and cools, the smaller the number. The bigger the number, the slower or the longer it takes to heat and cool. Okay? That's what you need to know about. Remember, I'm not going to ask you guys, for the most part, just straightforward definitions. All right, so number 5. So about half of us, maybe a little more than half of us, about 65% of us roughly, did number 5 great. Some of us just punched it in the calculator wrong. So some of us are not even using the calculator right. So if you got number 5 wrong on the quiz paper I just handed back, the reason I handed that back is you need to know that you're one of the people who is really mucking up number 5. So we can get the calculator portion right. All right, when you go to put in this times 10, how do you punch that in your calculator? That is second and EE. I think I have one calculator in here that you don't have to hit that second on. That there's actually an EE button that wouldn't require the second, but I think I only have one calculator that has that. All right, so 4.56, second and EE. That EE pops up and it means to do what? Tell it the exponent. Don't tell it 10. Just tell it the exponent, and it's asking for what? 7 plus 2.14 second EE 7. All right, now, when you get the answer, I told you yesterday, this answer has to be in scientific notation. All right, now, if it wasn't in scientific notation, what did I tell you to do when you got your calculator? Put it in scientific notation. How do you do that? Does everybody remember how? It's mode. Okay, mode, use your arrow keys, hit enter, and then clear it off the calculator. So I get 6.7 times 10 to the 7th. Now, when I look at my calculations here, I'm doing what in this question? Okay, what's the rule for addition? Decimals. So how many places behind the decimal here? How many places behind the decimal here? So how many have to be in my answer? How many are in my answer? And I have to have how many? I don't have 2. So I would mark that wrong on your quiz paper. I got to have 2 because my question needs 2, right? So what am I going to do? I'll add a 0 right there. Okay, it's the exact same rules that you used on the top half of the quiz that you use for scientific notation. The rules aren't different. All right, so for the bottom, oops, I don't know what I did there. Ooh. So for the bottom half of the quiz, all right, scientific notation again. Try on the second one, 3.56. Second, EE, what's that, 12, divide 7.23. Second, EE, 3 equals 4.9239 times 10 to the 8th. Okay? And again, I want to round based on what this time? How many are here? How many are here? I want how many in my answer. So I'm keeping 4.92. 4.92 times 10 to the 8th. I don't even know how y'all said 14. I'm just going to pretend that didn't happen. All right, questions about how I got the answer. Everybody okay with that? Anybody not? Salma, you feel okay? You okay with the opening? Everybody okay with what we just reviewed?
Yeah.
Everybody okay with that? Did you see it on the test Friday?
Yeah.
Destiny? Yeah. Guess I wanted to bail, but they said no.
Oh, what's this?
Feel okay about that?
Right? That's why.
Huh?
You're saying it's a school day?
I'll be here today and tomorrow, yes. The only day I won't stay, Monday I have meetings typically, and Friday is a religious holiday. I don't know if religion takes Friday off, but I'm certain there's one out there and I belong to it. Friday I just go home after school. Okay, but Tuesday, Wednesday, and Thursday I don't mind staying. It's just zinc metal. It's not gonna hurt you. You can touch it.
Oh, yeah.
Okay?
I will come.
I will be here. All right. Who else has a question? Anybody before we go homework? All right, let's look at your homework answers. See what kind of questions you have, if any. You might have some, you might not, but let's see what you got. Did you take it or just look at it? Zinc. It's just a metal. Somebody put it wet in the jar yesterday, so I had to put it out here to dry. You don't hurt anything. All right. Did anybody lose earrings, by the way? Because somebody found earrings on the floor yesterday. I just stuck them up there. But we found earrings in here yesterday. All right, question 1. You should have. I don't think that's the right paper. No, that's not the right one. This is the right one. Yeah. All right, question 1. There's 3 answers to question 1. The first answer should be negative 59 degrees Celsius. Good. The second answer in number 1 should be 318 Kelvin.
Oh, wait. What is the first one? 59.
Negative 59. Okay? And it should be degrees Celsius per unit. I'm not checking. I won't check every homework that we do. Take your headphones out. You didn't do it all for nothing. Hopefully it means you'll do well on the test Friday. The second answer in number 1 is 318 Kelvin.
Yeah.
And the last answer should be negative 423 degrees Celsius. Somebody tell me what's wrong with my third question in number 1. Anybody know what's wrong with my third question in number 1? Typo.
Instead of a degree of that.
Must be like.
That would be fabulous. We'll bring it back, put them over, and plug in. All right?
Was it not supposed to be negative?
It's not supposed to be negative. All right, Kelvin temperatures are not negative. All right? But we'll talk about it later in the semester. All right, number 2. You should get an answer of somewhere in the ballpark of 81.2 joules over grams degrees Celsius, which you need to round to one significant digit. So you should get an answer of 80 joules over grams degrees Celsius. 81 has one too many significant digits. Because remember, multiplying and dividing, you only want 1. Number 3, you want somewhere around 92.1 joules. But again, in this one, you want one significant digit also. So around 90 joules. Number 4, you want 0.4, thank you, 0.41 joules over grams degrees Celsius. And in this one, you also want one significant digit. So again, 0.4 joules over grams degrees Celsius. Number 5, you want 10.7 joules, roughly. And this time you actually get 2 significant digits. So I have 11. But if you rounded it to 10 with a decimal, that's fine also. And the last one, number 6, you get somewhere around 1,010 joules. And you need 2 significant digits, all right? So let's think about this. You have 1,010 joules, but you only want 2 significant digits. So how can you make that number 2 significant digits? Anybody know? You can make it 1,100, but that rounds it up quite a bit, okay? And there's nothing wrong with that. I would certainly not mark that wrong on you, Rebecca, because you have rounded that up, and you do have the right number of significant digits, so I would not get mad, all right? However, that's rounded up quite a bit. That's the way I do it, Gabriel. I would move it So you got 1.0 times 10 to the third. That way you don't round it up as much. All right, and you have two significant digits there, which is what you need. Okay? Questions about that? Okay? Now, does anyone need any of the questions worked on the sheet because you didn't get the answer right? It's not about significant digits. You just didn't work the question right. You don't know why. So everybody worked all of them right? Really? That's fabulous. Salma, you worked them all right? Did you work them all right? You mean do any of them?
No. That's on to you today after school.
Okay, you don't want me to do any of them now?
No.
Okay. All right. So everybody did them great? What are you, the local gopher or something?
Yeah, I guess so.
Oh. All right. In that case, moving on. If you will, find your notes from yesterday. Is there a wrestling meet tonight, Dylan?
No, we had one yesterday.
Oh, okay. I was just curious. They told me you only came to school on wrestling meet day, so
We did.
I thought I'd inquire.
Let me tell you, Dylan got what? He got.
Not very kind to him. Now, was that part of the dual, Dylan, was that part of the dual team? Was that part of the dual team when you lost last night, or was that just a match? I would say playoff.
But I wrestled, it was ranked fifth in state. This wasn't ranked at all.
This is a state ball.
Oh, yeah, I love this ranked right now. I don't know if you.
So did Hyro beat him, or did he get beat too? You got what too?
You take that.
Because they suck, yeah.
So does that mean y'all move on, or y'all got beat bad?
I got beat bad the second time. Right.
So are y'all done then?
As a team,
As a team?
we still got regionals next week.
Gotcha. So does that mean you and Dylan get to move on? Alright, so yesterday, we were talking about physical properties, right? And I saved this so that we didn't have to regenerate the entire list. Because we have to do something else with these properties, and quite frankly, I'm just lazy in my old age, don't want to run down again. Now, not only can we talk about whether properties are physical or chemical properties today, but we also have to learn how to label the properties as intensive and extensive. Okay? So, what does it mean to label a property as in, all right, let me say this first. Physical properties only are either extensive, go back, dumb thing, or intensive. Now, what does it mean to say something is extensive? Now, really, you just figured that out? Now, something that is extensive means it depends on size or amount. Intensive means it does not depend on size or amount. All right, so something that is extensive depends on the size of the sample of matter or how much is present. Something that is intensive does not depend on the size or the amount of matter present. For example, we're going to label these on the board in just a second. Color is intensive. if I cut your shirt in half, or I cut it into fourths, would the color change if I cut it apart? No. So the size of the sample would not matter. Its color would not be affected by its size. Now, if I was to talk about its volume, volume is extensive. If I were to cut it apart, would it have the same volume if I cut it in half? No, its volume would now be what? Half of whatever it started as. All right? Are you with me on that? Everybody got them one off the board? All right, we're there now. So if we go back here, we just said that which one? Color was intensive, and we had volume somewhere. Volume was extensive. So we want to label all of the rest of them on the board as either extensive or intensive. So where would height fall? Dylan, be quiet. If you can't be quiet, then you can move somewhere else in the room. Now, height would be what? Height would be extensive. All right? Length would be what? Extensive. Where would specific heat fall? All right, E or I, because I can't tell. All right, it is I. All right, lots of people want to say E there, but remember, if it's on your orange chart and it's listed for a particular element, does it change based on the size of the sample? No, so it's an I. It's intensive. All right, what?
So I thought specific heat was like,
It takes longer to heat up. That's time. Okay. So width. That's an E. All right. Weight. Density. It's on the orange chart. The density of water is 1. It doesn't change. Melting point. Boiling point. Both on the orange chart. Lots of people think those change based on the size of the sample. And this goes back to what Kevin just said a second ago. Water boils at what temperature? Can anybody tell me?
212.
212 on the Fahrenheit scale. I thought I heard the other one. 100 on the Celsius scale. All right. Now, sometimes it boils faster than other times because it depends on the amount. But it's faster. We're talking about time. It still boils at what? 212 or 100. The temperature doesn't change. So it's intensive. The only thing that changes is how long you have to wait for it to boil. Time is not a factor. Okay? Same with melting point. So we have what left? Texture or composition. That's what? My desk, if I cut it in half, would this side feel different from this side? No. So that's what? What about the composition or what it's made of? It's like the wood was, I think it was High Rose wood yesterday. So that would be what? That's I. All right, mass. E. Any questions about that? All right, physical properties. Now, physical properties, chemical properties. Sorry, we just did physical. Chemical properties cannot, everybody hear me say this, cannot be labeled as intensive or extensive. All right? These properties, first of all, alter the identity of a material. Okay? These properties alter the identity of a material. Okay? Every single bit of it alters the identity of a material. Now, examples of chemical properties that you guys would probably know something about, and I'm not going to list a great deal because we just don't know a lot at this point. Things that decompose. All right? Decomposing would certainly fit here. Most of you could probably tell me about rusting, or you could probably give me the fancy name. What's the fancy name in science for rusting? There you go. Things that have the ability to burn. What's the fancy name? Hang on one second. What's the fancy name for burning in chemistry class? Starts with an F. There you go. Flammability. All right, Tevin, what's your question?
Chlorophyll, like the color of my heat.
Hold on to that thought. That's coming very shortly. Okay? But those types of things are going to be chemical properties. We could also talk about reactivity here, which we're going to spend a great deal of time talking about throughout the semester. If any of you know anything about neutralizing something, I hope none of you have this problem at your age, but if you have reflux or heartburn, if you have to take some type of antacid, that would certainly fall there. Hopefully that's more of something your parents would have to deal with than you would. All right, but those would be chemical properties. Now, this is very short. Normally these would be on the same sheet of paper, but Genius here programmed copy wrong. So, hold on a second. One, two, serially. All right, this is very short. We're going to give you about 3 minutes.
Yeah.
All right, put a check in the column beside the right property. Is it physical or is it chemical? Like I said, about 3 minutes. Should be very quick. And then we're going to talk physical and chemical change, and then we're going to do the last.
What is luster?
Luster is shininess. All right, am I giving you enough time? That's closer to about 2 minutes. Are we good? Yes? No? Where we at? Sure. All right, so blue color, what'd you say?
Physical.
Physical. Density.
Physical.
Physical. Flammability.
Chemical.
Solubility.
Chemical.
Everybody always says that every year.
Chemical.
Physical.
Physical. Do y'all know what solubility is? That's why y'all get it wrong. Most people just don't know.
It's like dissolve.
It's like dissolving. Dissolving is a physical property. Okay? Being able to dissolve something is a physical property. So if you have that one wrong, move it to the right spot.
Isn't it caused?
Yeah.
Is it what?
Isn't it caused by like some type of chemical reaction?
Is it what chemical?
Caused by some type of chemical reaction.
We're going to talk about how to figure that out. That's why I do this one first, and then I'm going to clear up and tell you what to look for. Because most of you have no idea what to look for. I'm going to give you 5 things. If you don't see these 5 things, it was not a chemical property. Okay? And you're going to see all 5 of them very shortly. All right? A reaction with hydrogen to form reaction with acid to form hydrogen. That's chemical. Supports combustion. That's chemical. Do y'all know what combustion is? We don't talk about this semester. When a hydrocarbon reacts with oxygen and it explodes to form carbon dioxide and water. Huh? No, you're just gonna see it in a reaction. Sour taste. A lot of people think that. It's not chemical though, it's actually a physical property. Some things have a sour taste, some things have a sweet taste, some things have a bitter taste. Taste is physical. Melting point. It's physical. Reacts with water, form a gas.
Chemical.
That's chemical. Reacts with the base to form water. Chemical. Hardness. That's physical. Some things are hard, some things are soft. We're talking about elements up there that are hard, some of them are very soft. Some of them are something swishing with fingers. Some are incredibly hard. You probably talk about the Mohs scale in earth science, the hardness of rocks. Ball point. Physical. It neutralizes the base. Chemical. Luster is shininess, so that's what? Physical. And odor. A lot of people want to say chemical on that one, but it is physical. Some things just smell bad. Okay? All right, so that was part one of the lab you're doing today. Part two of the lab you're doing today is on physical and chemical change. Now, the definitions are very, very similar, so we're not going to spend a lot of time on definitions. We want to talk about how we can tell the difference. Okay? Now, the biggest thing about a physical change, all right, is we've already said that it does not alter the identity, right? I want you to remember, and this is the important part about a physical change, all right, is you will not get new materials or new properties. All right? You will not get new materials or new properties. Whatever you started with, you still have. Okay? They stay the same. Now, the easiest example to use for this, all right, is water. All right? Phase changes are all physical changes. And every year, students get this wrong every single year. All right? When we take water and we freeze it and it becomes ice, okay? It is still water. When we boil it and it changes into steam, it is still H2O. Water that changes into ice is still H2O. It is still composed of 2 hydrogens and 1 oxygen. It is not chemically different. Okay? Now, any phase change is physical. So, what are some phase changes that would fit here? Besides freezing and boiling. I know y'all had some kind of science before you got to me, so you know these. What's the opposite of freezing? I know you know that. There you go. What's something similar to boiling, but you don't actually boil? What? Okay. You heat it, but it didn't boil. The water did what? Okay, so it's simmering on the stove and it goes away. What happened to the water? It's the science word. It evaporated. Okay? All right, what's the opposite of it evaporated? It condenses, or it condensated. Now, sublimation might be one you don't remember. I'll put it up here because we're going to talk about it later. sublimation is a solid to a gas. And in case you forgot, condensation is a gas to a liquid. Liquid to gas is evaporation. In case you forgot those. But any of those phase changes are physical. Now, it doesn't have to be a phase change that's a physical change. You can have other things that are physical changes also. For example, you could grind something, all right? My kids like tacos. Old El Paso is their favorite. God bless them. But I don't like big chunks of hamburger. So we tend to food process it. I don't like to spend a lot of time chopping with a knife. Wears my hands out. So we put it in the chopper, chop, chop, chop. All right. So when I grind or chop, cut, tear, any of those words that we might use, those are going to be physical changes. If we do any of those things, have I altered the identity of any material? That's exactly right. All right. The word you just used a second ago, when you dissolved, did you do anything to it? For example, how many of y'all make Kool-Aid or tea? Y'all put sugar in it? Yep. What happens to the sugar? Is it still sweet when you finish? Did you alter the identity of the sugar? No. Okay. Dissolving is a physical change. Any questions about that? Now, so most of us can recognize that, but then still, when we look at it, you're thinking, well, I really can't tell if it's physical or chemical. So how am I going to know? Well, I'm going to give you 5 things to look for. And if it falls in these 5 things, it's a chemical change. If it doesn't have one of these 5 things, it's not a chemical change. Okay? Everybody got what they want? All right. So what is a chemical change? All right. A chemical change, first of all, will alter the identity of a material. You will get all new materials with new properties. Now, this is a great way to illustrate this. Everybody in this room, for the most part, can probably tell me what NaCl is. What's NaCl? It's sodium chloride. All right. Y'all know what sodium chloride is? Anybody know? It's salt. Okay. Plain old salt. Plain old table salt. What can y'all tell me its color is? White. Okay. I'll even tell you it's a solid. It's a crystal. And it's safe to eat. Now, you can't eat a salt shaker a day for 25 years and not wind up with some kind of heart issue. But for the most part, we can eat NaCl without difficulty. You go to the cafeteria today, you want to sprinkle some salt on your lunch, or are you going to drop dead? No. Okay, it's safe to eat. Now, sodium, on the other hand, all right, is a silver metal that explodes in water. Put some of that in your mouth. Kaboom. Chlorine is a yellow, poisonous gas. Sniff some of that, drop dead. Okay? But when you put the two of them together and they're allowed to react chemically, they create a white solid that is safe to eat. So they undergo a chemical change that allows these two things to become perfectly safe for you and I to be able to touch and eat without difficulty. Okay? So, how on earth would we recognize that these underwent a chemical change, but all these things underwent a physical change? Because there's got to be something that happens that says, aha, I can tell. All right? Otherwise, y'all are going to flunk the lab today. I'm going to grade a bunch of Fs. All right? And I'm not in the business of grading a bunch of Fs, despite what tends to happen some days. All right. Everybody got it? So, what are these indicators that I speak of? All right, the 5 indicators of chemical change. Now, I'm telling you right now, you will see all 5 today in the lab. Everybody hear me say it? So, in a little while, when you're all sitting around going, did we see that? Did that happen? The answer is yes. Number 1, the production of light. Okay? That is actually the indicator you see when you mix sodium and chlorine together. You get this big whoosh white light that happens. And so you know it was a chemical change. All right? So if you see a big bright white light produced, then you know it was a chemical change. Does that happen when you make Kool-Aid? No. Clearly that was not a chemical change based on that indicator. All right? Number 2, the production of a gas. How do you know if a gas is formed? All right, it could expand if it's in a closed container and the container expands. Let's say it's not in a closed container. Some gases don't smell. How do we go know? Clear, colorless, and odorless. Put a baby in a bathtub. How do you know they have gas? There you go. Okay? Bubbles. You're going to see bubbles. Number 3. Change in color. Now, I have to give you a little caveat to this one, because I have to say it has to be an unexpected change in color. Meaning, if you buy grape or purple Kool-Aid and you put it in water and it turns purple, that is not a chemical change. If you buy something that's red flavored and put it in water or ice cream and it turns red, that is not a chemical change. Okay? But if you mix 2 clear liquids and it turns bright green, is that what you would expect to happen? No. That's a chemical change. You and your chlorophyll earlier. Chlorophyll is what color? In the winter or the fall, what happens to them? And what happens to the leaves? And the leaves turn. Or before they turn brown. What color do the leaves turn before they die? Orange, red, yellow. Any of those pretty colors that people drive all the way to the mountains to see in October and September. All those old people, because you know the rest of us work. All right, they drive up there and clog up the mountains. Mountain people make tons of money on tourism because people are driving all over the place looking at leaves, okay? Because it's a color change and the leaves are undergoing a chemical change, okay? It's an unexpected color change. But if we just use food coloring or dyes and it changes the color we're expecting it to change, that is not a chemical change. Now, some people will say, well, what if I mix some blue and some yellow? Now, we all took art class in elementary school, right? If we mix blue and yellow, we learned in art class it was going to turn what? Green. If it turns green, is that a chemical change? No. Okay? And if you don't know that, ask one of your classmates. Number 4, the formation. This is a new vocabulary word for you. Of a precipitate. Now, you know a precipitate up to this point means sleet, snow, rain, or something from earth science class. In chemistry class, precipitate does not mean that. Precipitate means a solid formed from two liquids. So, two liquids are placed together, and when they mix, a solid falls down or forms from the two liquids, then a precipitate has formed. So, when you make Kool-Aid, do any of those things happen so far? Does light form? Do gases bubble up? Does an unexpected color change happen? Does a solid start forming and drifting down when you mix two liquids? So forming Kool-Aid or making Kool-Aid would be what kind of change? This one. All right, the last one would be a change in temperature. Now, changes in temperature can be one of two kinds, and you did these in biology class. The first one is called endothermic. So what's the other one called? I heard it back there. Say it a little louder. There we go. Exothermic. All right, so endothermic is heat is absorbed. Exo means heat is released. Those are really great definitions. However, they don't tell you anything about what's going to happen in the lab today. All right, how is it going to feel to the touch today if it's endothermic? It's going to feel how? It's going to feel cold. Something that's exothermic is going to feel how? Let's just put warm. All right, I'm not going to give you anything that's going to burn you. All right? Now, in order for you to know if there was a change in temperature, you're going to have to do what during the lab? Feel it. You're going to have to feel it or touch it. Okay, so the baggie that you're going to have and the test tube you're actually going to have to touch those things with your fingers to feel if they got warmer or cold. If you forget, there's nothing I can do for you. I'm not going to give you anything that's going to harm you, so you don't have to worry about that. Leanne.
Is that for the like us, because there's like a polar, like they keep all their heat in and we want to see out?
You can think of it that way, sure. Okay? Questions? So, when you think about making Kool-Aid, when you put your hands on the pitcher, now, if you just mix the sugar and the mix and the water together and stir and put your hands on it, does it get warmer when you stir it up? Does it get colder when you stir it up? No, there's no temperature change. Now, if you put ice in it, that's completely different. I'm talking about you had water, you had the pouch, you poured the pouch in, you stirred it up, and it got cold because you mixed them together. Does that happen? Have any of you ever bought those ice packs or cold packs where you have to shake them or pop the discs inside and start a chemical reaction? Okay, that's what I'm talking about. When you start it, it gets what? Let's just say you bought the hot pack. When you pop the disc or break it inside, the chemicals start to react, and it starts a reaction, and it gets hot on its own. When you mix the Kool-Aid with the water, does it get hot on its own? No. If it has a temperature change in the lab today, when you mix it, it will either A, get hot on its own, or B, it will get cold on its own. You're not going to cool it or heat it. It will do it because it's a chemical reaction. We're not adding ice. We're not heating it. Okay? Everybody hear me? Dylan's a prime example. He's an athlete. Have you ever put Epsom salt in water? What happens when you put Epsom salt in water? Okay, do you ever pay attention to the temperature of the Epsom salt in the water? Never paid attention to it?
I did too. It's supposed to be
Yeah. Do you ever pay attention to what the Epsom salt does to the water, though? Don't put it in hot water. The Epsom salt will lower the temperature of the water. It's designed to lower the temperature of the water. That way, let's say you have a sprain, okay? How's the sprain feel or the sore muscle feel? Warm, okay? Heat moves from where to where? Anybody know? From the where to the where? Hot to cold. So if let's just say he sprained his hand, and his hand's all hot and swollen. You put it in Epsom salt and water, which is cold, right? Hand's hot, water's cold. The heat will move from the hot hand to the cold water and draw the heat away from the hand, causing what to go down?
Swollen.
The swelling. Okay? But if you get in a hot tub of water, is the heat going to move from the hot hand to the hot tub of water? No. That's why you get into a cold tub or a cold pan of water that has Epsom salt in it. Okay? It pulls the heat away from it and causes the swelling to go down. Questions? All right? All right, if you will, we're going to practice just a wee bit, not much, and then we're going to do the lab. I'm going to put it in a hot bath. I'm going to do a lot more. Let's just suck the water out of you. For real? Oh no, I don't know why it all sucks the water out of me in a hot bath. You'd have to explain that one to me. Alright. I want you, and I'm not going to give you very long to do this. Alright, I want you very quickly to figure out if these are physical or chemical changes. And I want you to try to figure out if you say it's chemical, which of the 5 is the indicator? Is it a gas? Is it a precipitate? Is it a color change? Is it heat or light? The whole bag. Did you figure out what the indicators were when you said C?
Oh.
The wise one.
Wait, you said indicator would be like the light.
Light, gas. Yep. Another minute, and then we're gonna go over. did this past week. Oh, I didn't think about that. Could I do it in an hour? If they can do it in an hour, I would. If you can't do it in an hour, I do it Tuesday. That would be my advice. Yeah, I'd move to Tuesday. All right, number one, what do you say? Physical. All right, the word dissolves tells you it's physical, right? All right, number two is, what's the indicator?
Like,
Precipitate.
That's the key word in the question.
Oh.
You see the word heat?
change the
Change in temperature.
Oh, number two?
Number two, it says it produces heat. That's a change in temperature. Number three, a sodium carbonate sliced in two. That's physical. Number four, heat is changed to steam. That's physical. It's a phase change. Number five, potassium chlorate decomposes to potassium chloride and oxygen gas. It's chemical. What's the indicator? It's a gas. Number six, iron rust. It's chemical. Why? Color change. Y'all all seen rust. If you got a nice white car and it rusts, it turns what color? Brown. All right, number seven, water placed in sodium, or in water, sodium color catches on fire as hydrogen gas is liberated in sodium hydroxide form. You could say chemical, and why? Light, gas, and there's one more you could have said. Temperature change. Evaporation, physical, melting, milk souring. That is chemical. It will change color, first of all, in case you don't know that. We'll go from white to yellow, and it will curdle and make chunks. It's really nasty. Sugar dissolves in water. Physical, wood rotting.
Chemical.
It's chemical.
And color.
It's going to be a color change, and it's also going to do one other thing.
Yes.
Not necessarily a gas.
It's not dissolved. Not necessarily dissolved, but
It's going to change temperatures. It's going to get really hot. You ever seen steam coming off of a toast or wood pile in the wintertime? It's really warm. All right, number 13, unless you made, you would probably have no idea about. Pancakes cooking on a grill.
Physical.
I wouldn't say not.
And it's gas.
There you go. Because why, Rebecca? It bubbles. All right? It bubbles. When you cook pancakes on a grill, you get little holes or bubbles or gas are escaping. All right? And I would tell you this about food. Anytime you're cooking from scratch and you're actually cooking in an oven or on a stove, it's going to be chemical. If you're reheating in the microwave, it's going to be physical. Grass growing in the lawn is a biology question. Impress me.
Chemical.
Chemical. What process did y'all learn about biology class?
I was physical because it changed color. Right.
No.
Y'all really can't tell me what process y'all learned about grass growing? Yeah, photosynthesis. That's chemical.
But also changes
You can
color.
just tell me photosynthesis. It's going to produce a gas. Y'all make oxygen. All right. Food is, or tires inflated with air. Physical. Food is digested in the stomach. What indicator? Gas, temperature, and really, people?
Color change.
Yes. Last I checked, it didn't go in or come out the same color. All right. Water is absorbed by a paper towel. Physical. You don't think so? Check your lunch today. Pretty sure it's not going to look like it did when it comes out as it did when it went in, no matter what kind of cafeteria food they serve. All right. So there are two parts to today's lab. Part one, in the baskets on the back table, there are only 5 baskets set up, which means we're only using 5 counters today, okay? We're not using all 6 counters, so 1 counter should be empty, but there's enough in each basket for 2 groups. So I have enough set up for 10 different groups of people. All right, but I only set it up in 5 baskets. So at each counter, should there be two baskets? No. So if you go to the counter and there's only, are y'all listening? If you go to the countertop and there is only one basket there already, do not get another one. All right, there's only one per group or per countertop. Now you are going to have to wear safety equipment today simply because you are using real chemicals in the basket. The part 1 requires no real instruction other than for me to tell you this. In column 1 where it says observation or measurement, every year some group does something really dumb and they get really mad when I get the papers back. I'm not asking you for you to write observation or measurement. I'm asking you to find that information. So if it says volume here, I want you to measure the volume. Okay, not write the word measurement. Measure the volume. If it says color, don't write observation. What is the color? Okay? Length. Measure the length. Texture. Is it rough, smooth? Answer those questions, and what is the mass? I did not get out scales because I'm done with them. Just make sure when you find the mass, put it back. Okay? Remember your units. Remember your significant digits. How many places behind the decimal for a mass? How many behind the decimal for the rulers?
No, two.
Okay? For physical and chemical, you can write P and C if you want to make it faster. Make sure I can read them. And for E and I, make sure I can read it, or you can write out the whole word. I don't care. When you get to part 2, at some point after you've gotten situated, I will make sure that I've demonstrated part 1 before you get there. Part 2 and part 3 in the basket. Let me demonstrate very quickly. There are test tubes in each basket. Make sure that when you go to add the chemicals, please do not let the droppers touch the test tube. They should be held up here, not down in here. If the test tube is up here, can you contaminate my dropper with that test tube? No, because if this test tube here touches this dropper here, because you already had one touch and this one here bumps, you can contaminate this whole bottle. So make sure they don't touch. Once they finish, you're going to have a lead compound in here. Come back here to the fume hood. See this really nasty looking beaker?
Yeah.
That's just dried lead compound. Dump it in there, and then you can just put it back in your basket. Okay? Step 3, asks you to use the vinegar. Please leave the vinegar on the table. It says use a 50 milliliter beaker. A lot of them are dirty over there because I've got folks coming to clean them tomorrow. So some people have 100. It doesn't matter whether you have the 50 or the 100. Go to the 50. I think I said 40 milliliters. This one has a 40. This one's a little harder to see, but there's a 40. Just go to 40. Make sure when you do this is the only part you're going to be careful of. Make sure when you put it in, okay, that you squish all the air out and then finish sealing the bag. Once it's sealed, you can turn it over and start the reaction. If the bag's not sealed and you make a mess, who's cleaning it up? Y'all are. I'm not. Okay? Other than that, y'all got a half hour to get that paper to me. Once you give it to me, I'll give you your homework paper. The aprons are here. I need to keep off my desk. Open the bottle cabinet, which is here. Okay? I got to grab.
For the second period on Tuesday, but that's Wednesday.
And since I don't know who we're missing, if we're an odd man, put Dylan in the odd group again. Since he wasn't here, oh, pull this one.
How did you get those dogs back? Yes.
Oh, guys, don't waste your time. I got a little less than a half hour.
Oh, I just got through that.
Bill.
Hey, girl. Come here. Thank you. Hey.
Both of them.
Steak out there.
All right,